So in this video, the problem name is the number of islands, and previously we have solved this using DFS approach. So in the DFS, what we make is we make all the neighboring lands as visited, and will be counting the islands for one connected component. So this is actually the counting the number of connected components in the matrix form or else in the grid form. Similarly, we can also use breadth first search for finding the number of islands. So breadth first search uses queue for storing the neighbors and marking them as visited. So now instead of using DFS, what I will use is I will use BFS, breadth first search. So breadth first search uses queue for marking the neighbors as visited. So we'll copy this and change the name as BFS. Here from IJ, the BFS is going to happen and mark the remaining neighbors. How that will happen? Let us see. So let me take one example. 1 1 1 1 0 0 1 1 0 1 0 0 1 1 0 1 0 0 0 0. So 0 is representing water, 1 for land, 1 for the land. Okay, now we'll be searching the starting land and we'll be marking all the remaining other lands as visited. So in that way we can count the number of connected components. So what this for loop two for loops will do, it will traverse the matrix or else grid and we search whether and we check whether the grid is the land, so that we can visit the all its neighbors and mark them as visited, so that in the future we won't visit again even if it is a land. So here the this while traversing matrix we can see that at 0, okay, let me give the indexes 0 1 2 3 4 5 0 1 2 3. Now this one is we have given the indexes, and at 0 0 we can see that there is a land, that is 1. We can see that there is a land, then we mark all the neighbors as visited, so that one component will be completed, so that we can find the number of islands in this way. So BFS maintains queue, right? So I'll maintain one queue, and here we pass to the BFS function. Instead of writing here, I have passed this to the separate function, so that it can be solved in a separate way. Instead of writing here BFS, I have used BFS in the function form. So here queue will be created, created. So queue will store the ij values. Here initially queue is storing 0 comma 0, means the land. At 0 comma 0 we found our first land, and we will visit all its 4 neighbors. So 4 neighbors will be up right side, this is ij, and we can move down, and we can move left side. So this will be I minus 1 comma j. For moving down, I plus 1 comma j, and for moving right side, I comma j plus 1. For moving left side, I comma j minus 1. So in this way we will be moving. So for that movements, what I will be using, I will be using simply two arrays. For this will be for knowing the I direction, and this will be for knowing the j. Like here di will be for moving up, what we'll do minus 1. Dj will be uh, here we have for moving up, I will make I will I will become minus 1, I minus 1, and j will become 0. Similarly, for moving right side, I will become 0 and j will become plus 1. And for moving down, I become plus 1. So I will write plus 1 here, and j is 0, j plus 0. So in that way, what will be here? Here it will be I plus 0. So 0 and j minus 1. So in that way, I have written di and dj. So in this four, we'll be moving to the 4 directions. Or else here. Okay. Now we are at. I'll be using this to show you. Here we are at I comma j, right, initially, and we have pushed it to the queue. And next neighbor indexes will be x. Neighbor indexes will be 0, 0 minus 1. This one is 0, 0 plus 0. How this is computed? This is computed by I plus, or else I plus di of 0 comma j plus dj of 0. So in this way, we will be knowing that all 4 directions. So next direction will be 0 plus 0 comma 0 plus 0 plus 1. Next here this is added for moving right. Now 0 plus 1, here 0 plus 1, and 0 plus 0, this is again 0, and next this one is completed. Now this one 0 plus 0 comma 0 minus 1. In this way we can know the all 4 directions. So this one comes as minus 1 comma 0, 0 comma 1, 1 comma 0, 0 comma minus 1. So we have know the all 4 directions, and we check whether these are valid indexes or not. That is whether these indexes are lying in the given matrix, and also we should check whether this neighboring node is a land or not. If it is a land, then uh, we push it to the queue, and we will be traversing in the BFS using BFS approach. So in that way we are going to solve this. Okay, here I will be declaring queue of type pair of int comma int, so that we can store the I and j. Initially the queue is containing I comma j. So this So initially the queue will contain I comma j, and will be looping the queue until the queue is queue is will be looping until the queue is not empty. So int so let me pop one. So we need to pop let me call this as p. We need to q dot front q dot pop. So here I took the I comma j values in the some iterator, and what will be the this I comma j x is let us declare x is equal to, or else I will use I is equal to it dot first, j is equal to it dot second. So here what we have done, initially the queue is at 0 comma 0. I have started from here, right? So from here the BFS is going to start because that is the land. So now ij have passed as 0 comma 0, and there will be a visited array, visited grid, and there will same exactly as this, but that will be only boolean. Everything will be false. Now what I have to do, since I got ij, now I should move to 4 directions. So those 4 directions will be lying in the two mat. I have used two arrays for moving those directions. Direction. So now what will be the new direction? X is equal to I plus dx, or else di of 0, and int y is equal to j plus dj of 0. So in this way we are getting the 4 directions. These four these four directions values these 4 directions values we are getting. Not now what we have to do, we have to check whether this is a valid I comma j. That means these I comma j are uh, lying in the given matrix sizes. Otherwise this is out of bounds cases, right? Here -1 is out of bounds, so those cases will be removed. So if is valid, I have returned is valid function previously. So I have passing ij and n and m. I am checking whether those are lying in the given matrix ranges. So I should be greater than equal to 0, and j should be greater than or is equal to 0, and I should be less than n, and j should be less than m, so that this will make the neighboring neighboring I comma j to be in the given matrix ranges. So is x comma y are in the given range. If it is valid, then we need to check, it should not be visited, right? For suppose uh, for suppose it should not be visited. Here I will show you with the example. So I have pushed this to the queue, and I'll visit the next queue element. Next I will visit to here, and I visit to here and I visit to here and again I come to here. So we should not visit the same I comma j again and again. So in order to remove that, what I will do, I will only visit the non-visited lands. If it is not visited grid, so the name is visited grid and I comma sorry x comma y should not be visited and it should be a land. It should be a land, right? First of all, so we will check whether x and y double is equal to 1. Otherwise we don't visit if it is a water. So now we have checked these conditions. If all these conditions are okay, now we will be pushing to the q dot push uh, x comma y. Now x comma y is pushed. That means we can push this neighboring land. Here we can see. Let me copy this grid. Here erase everything. Okay. Now the queue will be starting at from 0 comma 0. Now we can visit the neighboring nodes as 0 comma 1 and the down one is 1 comma 0 and this is visited. We are popping here. So we will be popping the current one and we'll be visiting the remaining other remaining other nodes. So we need to make this ij as visited, right? So visited grid of I and j to be true, marking I and j as visited and pushing the neighboring nodes that are lands. Now this one bottom one is also land 1 comma 0. Next left side is not there, up side is not there, and we mark this as visited. So this one is visited and here now 0 comma 1. For 0 comma 1, what are the neighboring nodes? This one is popped out and mark it as visited. And what are the neighboring nodes? What are the neighboring nodes? So we should not push the same I comma j into the queue again and again, right? Suppose if we are at here, we will be again pushing because this is not visited. So instead of doing that, what I will do is um, I will be marking this as visited from right here, and I will mark x and y as visited here itself, so that we don't repeat pushing the uh, same x comma y or else I comma j into the queue. Like here we can see 1 comma 1. If we are at 1 comma 1, suppose we are at 1 comma 1, here in the queue we can see 1 comma 0, and for this all the four directions will be here in the left side we can see 1 comma 0 as one direction, one movement. So what we can see here, this is already pushed to the queue. We repeat the why should we repeat this pushing again? Like again we should not do the marking of visiting neighbors, right? So I'll mark it as visited when I when I push it to the queue. So I have pushed it to the queue, and while pushing, mark X and Y as visited, so that it won't get repeated in in the in the coming iterations. Okay, now we have pushed it to the queue, and this BFS will continue till there is no land. So now the BFS is completed. So I have to if the I and j are crossing initially, I less than n, or else I will check is valid I comma j and comma m, simply return. If it is not valid, case, then I should return from this function. And here why I have done is because if we pass I and j out of bounds cases, it can throw out of bounds exception. So for that case, I have used the I have checked this in the initial only, and I have declared the queue, and I have pushed initially I comma j, and this is the basic breadth first search algorithm, where I have used a pair as a to store the I comma j, and here I have took the front element and popped it from the queue, and I and j will be at it dot first this first element contains the I and second element contains the j, and I'll visit all the four directions and check whether the direction is in the valid range, like in the given grid range, and if it is in this range, it will return true, or else it will return false. And I check whether the grid of x comma y is land, that is the neighboring node is if it is a land and it is not visited, then I mark it as visited and push it to the queue and continue uh, this while loop till the queue is not empty. Now the BFS is making all the visited grid as visited, like a visited grid is making BFS is making the neighboring lands as visited, so that connected components count will be counting. Okay, now let me run this. I'm using BFS. We got 9 as our answer. How we got that? Here I have kept as a 0, so we did mistake. I need to keep the variable direction. I have took only 0 previously. Now I have kept the dir direction here, so that it can visit all its neighbors on the four sides. Now this one is worked. We can get the one as our answer. Let me Let me also see whether this one is working. Example 2 is also working. Now let me submit. Previously I have solved this using DFS. Now I have submitted the solution using breadth first search. Now what will be the time complexity of this? This is also same, like BFS is also uh, uh, using the n into m, or visiting all the n into m, right? And maintaining the queue will be also n into m, because suppose if all are lands, we need to maintain at least n into m, and this is also with the same complexity, but the approaches are different. Here I have used BFS, and that's it.